There's a piece of technology which I use nearly every day, and yet I've never given any thought as to how it actually works. It could well be magic for all I know, although it's probably not, but I decided I would learn about it and then explain it to you. So let's talk about near-field communication, or NFC, the technology which allows things such as contactless payments via your smartphone or access to public transport with a smart card. NFC actually works in a very similar fashion to both Bluetooth and Wi-Fi, and is based on the earlier technology radio frequency identification, now also known as RFID. Basically, sending the data over radio waves, 13.56 MHz if you want to know the exact details. However, these signals are not being widely broadcast over the airwaves. Instead, they are transferred between devices via electromagnetic induction. Put very simply, a powered coil creates a small electromagnetic field that induces a current in the other coil. As with everything, this is not actually a new technology, just a new and improved implementation. Here's an example of inductive coupling from 1910. There are three main types of NFC. One, card emulation. This allows a device to pretend to be another type of card. This is how your phone can be used to make payments, for example. Two is peer-to-peer. This enables two NFC-enabled devices to communicate with each other to exchange information in an ad hoc fashion. For example, using Android Beam to send files between two adjacent devices. Third is reader/writer. This enables NFC-enabled devices to read information stored on inexpensive NFC tags embedded in labels or smart posters. NFC tags contain two simple parts, the antenna and a small system on a chip, or SoC. During an interaction, the antenna picks up an external signal and activates the SoC. The system includes a tiny CPU and memory for storing information. The amount of memory is dependent on the tag but typically ranges from 48 bytes to 1 megabyte. This can also work the other way around, with a fixed powered reader and you holding the SoC embedded in a smart card, often seen used in public transport such as London's Oyster card or Sheffield's Travel Master, or this subway ticket from Glasgow in which you can see the coil and the chip if you hold it up to the light. The beauty of these tiny systems is that they need very little power, and so no batteries or anything are required. They get enough power to run from the inductive coupling, much like wireless charging functions. Due to the relatively small amount of memory available, NFC tags are usually encoded to a URL or other text record. The NFC data exchange format standard defines how this text is formatted to ensure interoperability between NFC chips and the devices scanning them. I have probably overlooked or simplified some of the details here, and if I'm honest, I wrote this script rather quickly, but hopefully that was a fairly interesting little overview. Thank you very much for watching, and Betty, we will see you tomorrow.